Hi, dear students. Well, after the break, this video record is to talk about the other meaning of a thin continuous line on an engineering drawing in the alphabet of that language. Okay, let's start. Yes, I already talked about and you studied on the other meanings of this line, thin continuous line. On an engineering drawing, it is used to extend the size of a feature. It is called, in that case, extension line. It is used together with the termination symbols to show the dimension of the feature. It is called dimension line. If there is a problem to solve graphically, then using thin lines, drawing thin continuous lines, we can solve the problem. It is, in that case, such a line is called construction line. And already talk about transfer lines. Drawing thin continuous lines can transfer abscissa ordinate or altitude values from one picture plane to the other picture plane, from one part of the drawing paper to the other part, for having the views as consistent with each other. Yes. Now, the other meaning of this type of line is on sectional views. It finds it as meaning, it finds it as usage on sectional views in sectioning. It is called, in such a case, on the image, section line cross-hatching line. Explain why, how. What is sectional view? I have some slides in my presentation. Yes, this is the first slide. It keeps an example to make a highlighting, in which case we replace a regularly created projection with sectional projection, sectional view. Okay, take a pointer and then this pictorial figure, I think it is clear, can be seen. Say that this is the frontal side of the object. At the frontal side, at the front side of the body, there is a hole. That circle in this pictorial figure, it looks like an ellipse, but it is the edge of a hole. Yes, there is a hole over there. At the left side of the prism, there is a rectangular prismatic slot. It is open to atmosphere in the horizontal direction at both ends, but it is blind in the vertical direction, in the down direction, open to atmosphere in the up direction. At the back side of this prism, there is a semi-cylindrical channel. Okay, now assume that observer, just to create its projection on the surface of picture plane, thereafter to find it on the surface of drawing paper in this direction for outputting the front side view. Okay, this is one of the rays of sight. This arrow corresponds to one of the rays of sight, which is sent by the observer. While observing the body in this direction, yes, this rectangular prismatic feature will be an obstacle for the visibility of both of the channels. See on the front view, this is the front view for this object in the first quadrant projection, and assume that this is our drawing paper. Okay, title block is here, over there. This is the front view, this is the top view. For the hidden features in drawing their projections, or it is views while the views are created, we use dashed lines. Yes, the channels are hidden, so this dash part, the part on the projection we have dashed lines, corresponds to the image of this semi-cylindrical channel, and this hidden rectangle corresponds to the image of this channel. It is at the left side. Well, at this point, inform you on another dimensioning rule. It says that if on a view the image of an entity is in dash form, means it is a hidden feature relative to observer, then avoid showing its dimensions on that view. Okay, this is a rule and it is strict to obey. Well, after hearing me on that strict rule, then think about it. Well, we need to show the height of this channel, distance from here to there, such a dimension. It is not allowed on this normally regular created view because the image of the entity is in dash form, entity is hidden. I can say similar things for this channel. So, well, it is the case. It is the only view on the picture plane to show the dimension, but over there, unfortunately, entity is hidden. What can we do? How we can take a right to show such a dimension? The answer is sectioning. It is an imaginary cutting process. One reason why a normal view is to be replaced with a sectional view is that we have some dimensions to show on the picture plane, but the entities are hidden. So, applying cutting process, have the image of such features for which the dimensions are to be shown on that picture plane as if visible. Okay, see how? See the next slide. It is the thing to imagine for that purpose. Imagine that we have like a knife. It is to be considered to use. We have a plane. It is called cutting plane. Okay, in our example, we know that for the visibility of these two channels, this frontal feature is an obstacle. Okay, with respect to observer. Okay, select a suitable cross section, and at the cross section, using such an imaginary knife, imaginary plane, cut the object. After making such a splitting, then remove away the obstacle. In this example, this part, okay, of the object is the obstacle. Okay, so throw it away. Imagine as if there were no such a part. Observe the rest. This is the remaining part of the object after the imaginary cutting process. Observe it in the direction for outputting its corresponding image. Now here, the image of the remaining part via visualizing such an imaginary cutting process it can be formed is called sectional view. And such an imaginary cutting process is called sectioning process. Okay, here on the page, we have the sectional front view of the remaining part of the object. This view is not the entire of the view of the entire of the object. It is just the image of the remaining part of the object. It is called sectional view. To be able to notice the reader that forming or creating this view, we imagine the frontal part. It would be otherwise an obstacle for the visibility of some of the entities for which we need to show the dimensions. make a highlighting. How we can notice the reader that the image is just a sectional view. It shows the image of the remaining part. Here is the answer. It is under agreement by using thin continuous inclined lines. For any kind of material, okay, it is the line format, thin continuous lines. Just by highlighting the solid surfaces being in contact with the cutting plane, those have been cut during the imaginary sectioning process. In other words, having or showing those inclined lines on the surface of solid parts of the body while drawing the view of the remaining part of the object, we can say that view is the view of the remaining part, and view is the one it has been obtained, it has been formed after the imaginary cutting process. Yes, in this regard, say the inclined, equally spaced inclined lines, okay, shown on the surface of the solid parts of the object which have been cut by the cutting plane are called section lines. Okay, these thin lines are called section lines. Since they are in the diagonal direction and hatching the surface of the solid feature, the lines are also called cross-hatching lines. That is the meaning. How about cutting plane line? In the alphabet of the language, you know, turn back to the table and then see it is another item, cutting plane line. Cutting plane line in accordance with ISO is in this format: thick terminal lines, and the intermediate part is in the appearance of an axis of symmetry. It is called cutting plane line. Cutting plane line corresponds to its meaning, corresponds to the edge of imaginary cutting plane. Yes, it is a valuable thing to inform the reader that which cross section has been selected for outputting a sectional view. Whether the object is to be imagined as cut, as if it were cut, as at which selected cross section. To answer this question, we draw the edge of cutting plane. Well, see to which picture plane cutting plane is perpendicularly oriented. In our example, it is the picture plane on which we have the top view of the object. Okay, cutting plane is perpendicularly oriented with respect to the picture plane. On its surface we have the top view. So if it were real, we would see it as H. Okay, since it is not a real feature, it is just an imaginary plane. It is it is for preventing some readers from misconsideration. We use a special line type for showing the cutting plane on the view to which it is perpendicularly oriented. It is called cutting plane line. Here, this special line, you see at the terminal part we have thick portion, other terminal part thick portion. Okay, and the intermediate part looks like axis of symmetry. It is the format which is used in showing the edges of cutting planes. It is called cutting plane line. Looking at such a view and seeing that there is a cutting plane line can directly understand that there is a cutting plane to consider it has been used for outputting the corresponding sectional view. In the format we have arrowheads. Arrowheads are to be placed in ISO format bringing the tip of the arrows into contact with the midpoint of the thick portions. Okay, the arrows are to be directed toward the side of the remaining part of the object. Okay, that side view is to be drafted or created as sectional view. In this example, this is the front view. Okay, and the arrows are toward the frontal picture plane. They imply that the cutting plane is the plane. It is to be considered as if it were used for cutting purpose, for outputting the view directed toward the frontal picture plane. So these arrows to their directions imply that the corresponding sectional view is the front view, sectional front view. At this point, I want to make a highlighting that well, the cutting plane line format is completely different in accordance with ANSI. Yes. Well, this is in ISO representation. That is the format for a cutting plane. Yes, terminal part thick, intermediate part is a thin line. 0.5 line group, the thickness of terminal part is 0.5, and the intermediate part, that of intermediate part is 0.2 millimeters, as I already informed you that it is so. But in American format, creating the or drawing the third quadrant projections, we use this format. Well, a cutting plane line is a thick line. Okay, and along the line of action of the line, we have long dash, double short dashes. But in ISO format, you see long dash, single dash, long dash, single dash. But in ANSI format, double short dashes, and the line is entirely a thick line. How about the arrowheads? These are just to direct, indicate the picture plane. On that picture plane, the sectional view is to be formed. Well, in ISO format, the tips of arrowheads are to be in contact with the midpoint of the terminal portion. But in American format, the tail of the arrowhead is to be in contact with not the midpoint, but the terminal point of cutting plane line. Okay. And then, yes, some examples, section lines or cross-hatching lines. That is the meaning of, another meaning of thin continuous line. Whenever we see over a certain projection, on a certain projection over a certain surface, equally spaced inclined lines, then this means it is a sectional view. That view is a sectional view. And also, which part of the projection we have cross-hatching lines, this means those parts are solid parts cut by the imaginary cutting plane being in contact. Well, similarly, if the object is a building, is a house, yes, as I already mentioned, talking about say what the plan views, okay, elevation views, plan views. One of the previously recorded video film, yes, I already briefly talked about sectioning. Yes, imagine that we have a cutting tool, well, cutting plane, cut the building at a certain cross section, remove away the obstacle here for the visibility of the inside of the house, the roof, the part where we have the roof structure of the building is an obstacle. Take this obstacle away and then observe the rest. Well, in this direction, observe the remaining part and obtain this view, top view. It is called in the jargon of civil engineers and architectures a plan view. Sectional top view is called plan view. Well, cross-hatching lines. This part is the surface of a solid portion. There is a wall over there, and it has been cut by the plane. It is to be highlighted that it is a solid surface of a solid part. Using cross-hatching lines for any kind of material we can use. But some cases, if the scale of the projection is small, so cross-hatching lines, not so distinguishable. Even it is allowed, can fill in the surface with a paint. For instance, black has been selected in this example. Well, similarly, see, this is a house, and the cutting plane is over there, and then you see the obstacle has been removed away, and the remaining part is now observable, directly observable, as if observable. And then, well, observing this remaining part in that direction, have it is corresponding orthographic view, sectional top view. It is called plan view. Well, in mechanical engineering drawing, for any kind of material, the same style can be used, equally spaced inclined lines. But in architectural and or civil engineering drawing, well, to be able to make a highlighting that there are different layers on an assembly drawing, building is an assembly, so its projection will be in general an assembly drawing. Well, in assembly drawing, on an assembly drawing, to highlight that we have different layers made of different material, architects, civil engineers use different hatching styles. Okay. For instance, equally spaced inclined lines. In this example, this detail view have been used to say that this layer is made of brick. But here the hatching style here is completely different. It is to say that it is the surface of the earth. And say this hatching style, while this part of the projection we have another hatching style, it is to say that that part is made of concrete. Yes. This slide you can see the commonly used hatching styles for the civil engineering architectural materials. Okay, if on the view the part corresponds to the earth, then this on the sectional view this hatching style is used. Not a matter the view is plan view or sectional elevation view, the same hatching style is used. If the part is a rock, made of rock, then this hatching style is used. Well, the part we have gravel or crushed stone, this hatching style is used. For saying that that part is made of concrete, we use this hatching style, and so on. Okay, but for mechanical engineering drawings, for any kind of metal, any kind of material, this hatching style is used. Okay. If the layer is for insulating the building from outside or inside, well, to prevent excessive heat transfer, to decrease the amount of heat exchange from the inside to outside or vice versa, we use special materials. These are in general called insulation materials. If it is a soft insulation material, bad insulation, then that is the hatching style. But if the insulation material is made of hard material, if the insulation layer is made of hard insulation material, then it is called in general rigid insulation, and this hatching style is used. Okay. Well, repeatedly using the hatching styles again and again, in time those can be learned by heart. Okay. This slide is about some mistakes. Those were in question in hand drafting, of course. Well, this is a wrong hatching. Why? Because the space between the hatching lines are not equal to each other, and although the surface has been ended over here, you see the hatching lines have been furtherly extended. It is a poor practice. This figure, the hatching is incorrect because the line thickness is wrong. Don't forget, cross-hatching lines are thin continuous lines, not thick. Well, this is incorrect. Why? Because the space is not comparable, not a suitable space in order with respect to the area of the surface to be hatched. Exaggerate the case. For instance, this is the surface to be cross-hatched, and selected space value is extremely too much. So over the surface, even you may have only one hatching line. Just providing such a sectional view, how you can expect that the reader would distinguish that it is a sectional view. One hatching line is not sufficient to make a highlighting. In such a case, relative to the size of the surface, decrease the space value, so be able to have more hatching lines. So what I mean, the space value is selected relative to the size of the surface, which is the surface to be highlighted via hatching lines, using hatching lines. Inventor AutoCAD. Well, Inventor, no doubt, can automatically generates a suitable space value for the hatching lines whenever sectional view is created. In the structure of Inventor, there is a subroutine. Whenever the sectioning process is started, a suitable space value for the cross-hatching lines is generated. In AutoCAD, it is not so straightforward. We use trial and error method. Well, we ask the hatching lines, okay, if we cannot find them as suitable to their space value, then make another trial, changing the space value. Later, talking about sectional views in detail, I'm going to demonstrate how the hatching distance can be changed in 2D AutoCAD environment. 3D AutoCAD environment, similar to Inventor, AutoCAD can generate a suitable space value for most of the cases. Well, another hatching rule says that avoid having the cross-hatching lines as parallel or perpendicularly oriented with respect to the boundary lines. This is a poor practice because the hatching lines are parallel to the boundary of the surface. This is poor practice because these hatching lines are perpendicular to this boundary of the surface. This one is correct, preferable. Inventor AutoCAD cannot control or check whether hatching lines are parallel or perpendicular. It is to be controlled manually. Well, to the end of the semester, I'm going to refocus your attention to the sectional views, and at that time, I'm going to educate you how the hatching angle can be changed. Okay, this is just an introduction course, introduction chapter, and introduction part. It is to introduce you to the sectional views. Okay. If for outputting sectional view need to cut the body, need to imagine the object as completely cut, yes, the cutting plane extends from one side to the other side. Yes, like this. the sectional view from another point of view is called full sectional view. This is a full sectional front view. This is a full sectional front view. Yes, you see cutting plane is to cut the body entirely from one side to its other limiting side. It is called full sectional view. Yes, this is also a full sectional view. But some cases, well, if we cut the body for having the image of the hidden features as if those were visible, then we may not show the images of the exterior entities. If, in a case on the view to show we have some exterior features and also interior features, then instead of cutting the body entirely, we cut the object partially. Partially created sectional view, the sectional view, it shows a certain part of the object as if it were cut, is called broken out section. Yes, broken out section. Partial section. Here, this cross-hatched part corresponds to a broken out section. Well, at this point, can't find the meaning of another line in the meaning of another line in the alphabet of the language. Please pay attention to this wave line. It's a thin continuous line. It is to separate the sectioned part from the unsectioned portion. It is just a boundary line. To be able to draw the attention of the reader that the sectional view is not a full section but partially created one, we use such a wavy boundary line. It is called in general break line. Okay, break line. Yes, it is another letter in the alphabet of the language. See this reference slide. Yes, break line. Thin continuous wave line. Later I'm going to educate you, how a broken out section can be created. Answer this question. Share the corresponding video film. But here still talking about the types of lines and their corresponding meanings. For broken outs, for break lines, there is one more meaning. In this example, we have break lines, these wavy thin lines, just in general are called break line. But the meaning of these wavy lines on this view is completely different. These are not to say that there is a broken out section. These are to say that the intermediate part of a long object has been omitted on drawing this projection, such a projection. Yes, whenever the entity is a very long entity, to fit its image over a certain limited working space, and the geometry and the size of the entity is the same from one end to its other end. Geometry is not changing, size is not changing, so why not? We may omit the projection of an intermediate portion. Only show this part and the other part. And the intermediate portion between this and that is omitted. And as if there were no such an intermediate portion, the image of the long feature is drafted. To be able to highlight that the intermediate part of such a long feature has been omitted, has not been shown on this view, yes, use break lines for highlighting purpose. Parallel two wavy lines are used. Well, one wavy line is to terminate the image of this remaining part. The other wavy line is to bound the other portion. And the intermediate part has not been shown. Okay. Well, in other video record, I'm going to demonstrate how can create such a foreshortened view, how a broken out section can be created. Okay. Here in this example, this wavy line to say that the rest of the projection of the rest of the object has been omitted, has not been shown. Okay, well, it extends beyond this boundary, but it is the image of that part, the other part has been omitted, has not been shown on this view. Yes. Okay, then, well, completed the part in my lecture. It is about the meaning of a thin continuous line, and also opening a parenthesis and talk about the meaning of cutting plane line and also break lines. Okay. Next video record is to demonstrate how a sectional view can be created in Inventor, how a sectional view can be created in AutoCAD, using, of course, solid models at the background. I'm going to answer these questions. Or why not say I changed the decision. Okay, then continue and then see my demonstration. In AutoCAD, I'm going to demonstrate how a sectional view, full sectional view, can be created if there is a solid model, of course, saying that view created, not drafted. How a sectional view is drafted, I'm going to, in two-dimensional AutoCAD usage, I'm going to answer this question later. But here, this demo is just to demonstrate there is a solid model in AutoCAD and our purpose is to create the sectional view. I'm going to use this example. This is a body object, okay, and while we're observing the object in this direction, see, well, change the visualization style, okay, say that observing the object in this direction, the rectangular prismatic feature will be an obstacle for the visibility of the inside of the body, for the visibility of the things which is at the inside of this rectangular box, prismatic box. But of course, say that we need to show the dimensions of the features. These are within this box. What can we do? We need to replace, say, a full normally created view, normal view, regular view with a sectional view. Okay, using this solid model, I'm going to demonstrate how a full sectional view can be created in AutoCAD. First in AutoCAD. Well, I'm going to skip the preceding and following parts because I already educated you on such things. How the paper size after clicking on layout button can be changed. Okay, how we have the margin lines and title block as pasted on such a white page. Already studied on such things, but here my purpose in this CAD demo just to answer specifically how a full sectional view can be created. In answering this question, I'm going to define this side as the top side, and well, observe the body in this direction for it is top side view. Well, object is symmetric, and good practice is that cut the body at the symmetric cross section. Okay, cutting plane in this example going to be oriented as perpendicular with respect to the picture plane of the top side view. So on the top view can see it is H view. Cutting plane line is to be shown, can be shown on the top side view. Okay, see how the view, sectional view is created. Start the view creation process, writing this comment, view base. Select this option. And AutoCAD asking me whether gonna use the existing model for creating its views. Yes, in model environment, the solid model still active. Clicked on model space button, and then AutoCAD started to simulate one of the side views. I think this is the wrong side view, so change the orientation to be able to create the sectional view. First we must create the view on which we have the H view of cutting plane. We have the cutting plane line, we need to define the cutting plane line. Okay, in this example it is the top side view, so clicked on down direction key, and from this list of the options select orientation option and teach to the software that not the front but the other side image will be created as the base view, on which view we're going to have the cutting plane line in the end. Then define that view as the base view, if of course you're going to create a sectional view. Yes. And then scale factor, well, I think can increase the scale factor relative to the size of working area regarding the size of the object. I clicked on down direction key, and from the option list gonna select a scale option, not 1 to 2, but I'm going to use 1 to 1 scale, so the factor is 1. Press enter. Yes, this is better, I think, in size. Well, first quadrant projection, top view is created over here. Okay, so I brought the cursor to such a location. With a click I indicated it, and then, well, if the front view, say after clicking on exit option, then if the front view were required as a normally created one, I would move the cursor in the up direction and with a click show it is location. But my purpose here is to create the sectional front view, so I'm not going to create the regular view, just moving the cursor and clicking. Instead of doing this, just to be able to finish the running view creation stage, well, I'm going to create such an unnecessary view, making such a click over here. Next to top view, we cannot have another principal view. Well, here, just to be able to finish the execution view creation process, I'm going to create it. Right clicking, then after indicating the location for that view with a left click, and then right click the mouse and select from this list, enter option. And after creating this unnecessary view, I'm going to delete it. Indicate it with a click, then push delete button. How about the front view, sectional front view? Start the sectional view creation process. Okay, view, writing this word, well, this list will drop. From the list, select in that case not view base, view section option. Okay, I'll start the sectional view creation process in AutoCAD, and AutoCAD saying that select the parent view. Parent view here corresponds to the view on which we're going to have the cutting plane line. In our example, it is the top view. Bring the cursor to the vicinity, and after seeing this highlighting, this changing, and make a click. Okay, after indicating the parent view, then specify start point. It is written within the first compartment of the train. Start point. It is the starting point for the cutting plane line. Along the status bar, I toggled on track button for my convenience. So you see, after bringing the cursor to the vicinity of a snappable point, indicate a point it can snap cursor, and move the cursor away, I can see in the screen such a track line. It appears between as the line passing through the cursor and the characteristic point. We can have such lines, useful lines to follow, keeping this button along the status bar, object snap tracking button in on status. Okay, bring the cursor to the vicinity of the midpoint of this boundary. It is at the symmetric cross section. To teach to the software that gonna cut the body at its symmetric cross section, yes, do it. Move the cursor to the vicinity of such a point. It is at the symmetric cross section. It is the midpoint of the boundary. But don't click. Move the cursor away. Yes, track line has appeared in the screen. Follow the track line. You may consider this tracking line as if it were the edge of imaginary cutting plane. Well, locate the thick terminal portions minimum 10 mm away. So move the cursor away from the most out boundary, minimum 10 mm away, and then with a click say that it is the starting point. And then move the cursor to the other side. Okay, again following the track line, and reach to such a cursor position it is 10 mm away from the most out boundary. Make the other click. It is to indicate the other terminal point of the cutting plane, and then right click the mouse and then say enter. Yes, right click the mouse and select enter option, and then the rest. Move the cursor in the correct direction. Front view is created above the top view, so move the cursor in the up direction and with a click locate it. And then from the option list select exit option. Yes, the rest is achieved by the software. You see the created one is sectional front view, and pay attention to the cross-hatching lines. You see cross-hatching lines are equal, and these are over the surface of solid parts cut by the plane. The rest, well, write the preceding word section AA. By the way, yes, it is necessary to identify cutting planes, writing the letters of alphabet. For the first cutting plane, it is to be used for outputting the first sectional view in the order. We select the first letter of alphabet and write the identification letters next to the arrows, AA. And thereafter can say that cutting plane AA, and the corresponding view is called section AA. Sectional view AA. Yes, in this example in AutoCAD, you see cutting plane AA. AutoCAD put the identification letters, and in the vicinity of the corresponding view we have this phrase AA. But the good practice is that well, write the preceding word section. Okay, later I'm going to educate you on text facility of software. Using the text tool you can write the preceding word. But here in this video record, I aim to demonstrate how a sectional view is created in AutoCAD. How about Inventor? In Inventor, yes, the model of the object is in Inventor environment. Okay, in Inventor, I'm going to demonstrate. Well, first start from here. In Inventor, it is a new generation software. There is today such a animation tool. Well, in 3D environment, we can animate the sectioning process. Well, select View tab and in visibility panel, find this facility, section facility. Select this option and then indicate that surface of the solid model. And imagine that this is, well, after making such a click, a plane appears in the screen. Say that it is the imaginary cutting plane. And then move the cursor holding the golden arrow. Okay, and then select different cross sections. While you're changing the cross sections, can see at the cross section what you have, which parts are solid, which parts are empty. Yes, you can make such a demonstration, well, to say what is sectional view and at the cross section which features exist. But say this is for animation purpose, just demo purpose. This cross section, that is the geometry. This cross section here is the geometry. That cross section, that is the geometry. To be able to use the sectional view creation tool of Inventor, well, this animation is not needed. This is just is the tool to demonstrate the sectioning process, to decide which cross section is the most suitable cross section for outputting a certain sectional view. Okay, after this demo and informing you on the function of this facility, clicked on this close button, cancel, and then for this object, create the sectional view. Later, to the end of the semester, a little bit deeply talk about sectioning, but here just for demo purpose, clicked on new file creation button, and then here from this pane in Inventor, you know, we select unit system, and also if it is the case for creating a view or views of an object, making selection on metric option means we selected first quadrant. Making selection on English option means we selected third quadrant. First quadrant metric, and drawing template option is iso.idw. Clicked on create button and then start the view creation process. This is the button to click to start base view creation stage. And then, yes, this is the site. Teach to the software that not this site, but clicking on this arrow, rotating the solid model at the background, be able to direct the side of the object to have it is corresponding side view in the simulation as parallel to the drawing paper. It is, I know, that the top view of the object, and then, well, move the cursor, click for the front view, for the other side view. No, my purpose is to replace regular front view with sectional, so cancel this one, only create this view. First style button must be on, and the scale factor is good enough, 1:1, and then say OK. And then after having the base view on which need to show the cutting plane line, start the sectioning process. In AutoCAD, you know, writing view command, and from the list it will appear in the screen. Select view section option. But in Inventor, in creation panel, along the place views ribbon, we have a special push button on which it is written section. Clicked and then start the process. Indicate the base view, parent view first. Move the cursor to the vicinity of the image. It is the view on which we are going to have the cutting plane line. After seeing the dotted frame around it, this means you can indicate it. This means cursor is sufficiently close and the view can be indicated. With a click indicate, and then, well, similarly bring the cursor to the vicinity of the characteristic point which is at the symmetric cross section. In this example, we need to cut the body at its symmetric cross section, of course imaginarily. Well, at the symmetric cross section, this midpoint is one of the characteristic points. In Inventor, highlighting is done by using a little green dot. Okay, don't click but move the cursor away. Similarly, in Inventor, track facility is automatically enabled. Okay, there is no need to click on status, the button, track button on status bar. There is no such a thing actually. It is automatically distinguish that is the purpose, and cursor is to move along such a track line. Track line appears in the screen. You see between that characteristic point and the cursor there is a dotted line. Consider this dotted line as if it were the edge of cutting plane, and after being sure that you almost reach to a certain location 10 millimeters away, make a click and then move the cursor in the opposite direction. This thin line appears in the screen. It corresponds to the edge of cutting plane. Well, in this example, cutting plane line is to be horizontal oriented because cutting plane is perpendicular and with respect to horizontal picture plane, parallel to frontal picture plane. When the cursor reached to such a location at the opposite side, again minimum 10 millimeters away, make the second click to say that it is the terminal point of cutting plane line, and then right click the mouse. Don't forget, it is tricky. Right click the mouse and clicked on Continue tab. In AutoCAD, clicked on Enter key or clicked on Enter option, but in Inventor, clicked on Continue tab. Right click the mouse and clicked on the tab on which it is written Continue. And then front view is created in the say above the top view. So move the cursor together with the illustrated simulation in the up direction, and then with a click locate it. That is it. Inventor, yes, created the sectional view, and you see identified the cutting plane line with the letters, and the corresponding view you see written AA. Yes, I'm going to skip the symmetry axis indication stage, etc. My purpose, as I said in this record, just to demonstrate how a full section can be created at this stage, of course. Okay then, well, thank you for your watching. I finished my talking about the meaning of thin continuous lines. Stay healthy, stay in safe. Bye bye.